Okay, so here's section 6, everybody. This section, we're taking a step away from looking at angles and arcs, their measures, and now we're going to look at the lengths of segments and how segments are split and related to each other within circles. So in here we're going to have three types of segments intersecting circles, three types of situations. So we have this first one right here where you've got two chords. Then you have this one right here which has two secants that intersect outside the circle. Here they intersect inside the circle. And then here we have a secant and a tangent. So from here to there. Okay. So depending on it, you want to decide which of these three you're going to be working with. If it's this one, here's the formula you're going to be using. And what this formula says is that this tangent, this part that's just on the outside that doesn't actually go into the circle, it's a tangent line, that length squared is equal to, on the other part, this side, just this outside part, times the whole thing. So here I have B plus C. B is this outside part, C is this inside part. If you add it together, that tells you the whole length. So here I kind of have that formula in words down here. You take this tangent segment squared, and it's equal to the length of the outside part of the secant times the whole length of the secant. Okay. Option number 2 is when you have two secants meeting outside the circle. And for this, we're going to take, looking at each secant, notice how A and B are together and C and D are together, and those are part of the same secant. So A is the outside part, B is the inside part of the same secant, and C is the outside part, D is the inside part of the same secant line. So if you take the outside part times, so A times A plus B, which would be the whole thing, of this secant, that's going to be the same as if you take C times C plus D, so the outside part times the whole thing of this one. And then the other option, the final possibility, is when you're given two secants that are meeting inside, or two chords. Technically these are chords, but we're just talking about because we're looking at where they begin and end. And so here what you have is each chord is split into two parts. So A and B are the two parts of this chord, C and D are the two parts of this chord. And if you take these two parts multiplied together, it should equal these two parts multiplied together. That's what this formula says. Alright, so the first thing that you're going to have to do on these is figure out which of the three formulas you're going to use, and then you're going to go ahead and set it up. Alright, so this first example here, you want to find ML and JK. So ML is this length right here, and JK is this length right here. But in order to find those, we have to figure out how long X is, or we have to figure out what X is. So looking at our three possibilities, the one that matches this picture would be this one. So this is the formula I'm going to use, which says looking at this chord, this part times this part equals, and then looking at the other chord, this part times this part. And as far as, going back to this formula for just a second, as far as, because we're multiplying, it doesn't matter which part you make the A and the B and which part you make the C and the D. The only thing that does matter is that the A and the B have to be a part of the same chord, and the C and the D have to be the two parts of the same chord. So, on this example, I'm going to take, I'll let this be my A and this be my B. And so I'm going to have x plus 2 times x plus 1 equals, and then I'm going to make this be my C and this be my D. And so that's going to equal x times x plus 4. And then we are going to have to distribute or FOIL x squared plus 1x, and then go inside to the 2 times x, that's 2x, and 2 times 1 is 2. Then we just need to distribute this x through, x squared plus 4x. Now we've got our equation all set up, we just have to solve. First thing we can do is we can subtract x squared from both sides, and that's going to just cancel out. You can also combine those terms together to give you 3x plus 2 equals 4x. Then subtract the 3x. Gives you 1x, so x equals 2. So now we can go back over to our picture. We can figure out this part right here is x plus 2, which would be 4. This part here is x plus 1, so that's going to be 3. So the length of ML is, this part's 4, this part's 3, so that whole length is going to be 7. Because now that we know the lengths of each part, we are going to add them together. That would give me the whole length. And then to find JK, this part here is going to just be 2. This part here is going to be 6. So that gives you 8. And I do want to just point out for just a moment on here, notice how we're not saying that the whole lengths of those two segments are the same thing, because that's not the case. It's just the product, meaning multiplication, of the two parts is equal. So if you take this part, which is 4, times this part, which is 3, you get 12. Okay, the whole thing is 7, but it's split into two parts that multiply together to give you 12. This one is split into two parts, 2 and 6, which creates a whole length of 8. But when you take the product of them, 2 times 6, you get 12 also. So it's the products of the two parts that's the same, not the lengths of the segments in general. Okay, next example, here we have, we're trying to find the value of x. X is right here. So first thing we have to do, again, we're looking at segment length, so we're checking out our segment length stuff. But first thing we need to do is decide which of our examples it is. So it's not going to be the same one we just used because they're meeting on the outside. The two line segments come together on the outside. So then it's a matter of, is it two secants or is it a secant and a tangent? So I'm going to go back to the picture for a second just so you can look for sure. So this one, RT, touches the circle at 2 places, so that's not a tangent. And RP touches the circle at 2 points, so that's not a tangent. So it is going to be this one. 2 secants meeting outside the circle. So what we're going to do is we're going to start by figuring out our A and our B. And the important thing, again, with the A and the B is that those are on the same line. Okay, we got to make sure we use the same line for that. So I'm going to make this one my A, and whoops, backtrack for a second, sorry. So I almost messed up there. So two things. First of all, we have to make sure the A and the B are on the same line. The other piece is that the other piece that you have to make sure of is that the A and the C have to be the outside part. Okay, so for the formula to work, the A and the C have to be the outside part, because as we said, it's the outside part times the whole thing. So it needs to be 4, which is the outside part, times the whole thing, which would be 4 plus 5. And then I'll do the same thing with the other segment, except that's going to be my C and my D. The C has to be the outside part, though. So I'm going to set that equal to the outside part, which is 3, times the whole thing, which would be 3 plus x. So here we can go ahead, when we're able to simplify inside the parentheses, we can do that, or you could distribute and then add. It'll end up giving you the same thing. 4 plus 5 is 9, so 4 times 9 here, which is 36. Here we have to distribute because I cannot combine a 3 and an x. Those are not like terms. So that gives me a 9 plus 3x. And so then I'm going to subtract the 9 from both sides. 36 minus 9 is going to be 27. Divide by 3, and x equals 9, which is B. Or sorry, D. Circled the right one, said the wrong letter. The answer is D.